Exercise 5 here of chapter 6 is a really important exercise. It's simple and straightforward, but please don't skip this one because the skill that you will learn in this exercise will it has wide-ranging applications. I use this stuff all the time when I'm teaching about and experimenting with linear algebra. So the goal here is to create a matrix, a random matrix with any arbitrary rank that you want. Of course, that's subject to the constraints that I discussed earlier in this chapter. So it doesn't have to be a square matrix. It can be a non-square matrix. You want to create any m by n matrix with rank r. And as long as the rank of, or as long as r is fits in with the constraints that I discussed in this chapter, you can create any size matrix with any rank you want. So to do that, it's pretty straightforward. You just multiply a random matrix, so a matrix of random numbers that is m by r, times another matrix that is r by n. Now, you know from the rules of matrix multiplication that this matrix times this matrix is valid as long as the inner dimensions match, and in this case they do because they're both r. And the product matrix will be defined by m and n. So this is how we create a random matrix with all random numbers and a rank that we get to choose. Okay, so implement this in Python, confirm that the rank is r, and then what happens when we set r to be greater than one of the main constraints on the rank of the matrix, which is that the rank of a product matrix cannot be bigger than the minimum of m or n. So it can't be bigger than the smaller of the number of rows or the number of columns. Okay, so now I will switch to Python and show you my solution for this exercise. You can see that you don't need a lot of code for this exercise, which is great because the concept is important and it's pretty straightforward. The code that you need to create a random matrix of any size with any rank is tiny, which makes it really, really useful. If you haven't been able to tell, I'm a big fan of this method of creating a matrix. Okay, so I set m to be 5 and n to be 8 and r to be 3. So we are going to create a 5 by 8 matrix with rank 3. Let's see if this works as planned. And it does, 5 by 8 matrix with rank 3. We can run this multiple times. Each time I run this, the matrix is going to be different. I can even print out this. Let's print out A. You can see that A is just a bunch of random numbers. And, when you look at these numbers, it's not obvious that this has a rank of 3, but that's what it has. Now we can make this have a rank of 4. I think I'll just make this look a little bit cleaner. I'll get rid of that. Rank 4. Okay, so now let's see what happens when I set r to be 6. Now that's bigger than m, the smaller of the two dimensions. So can we get a 5 by 8 matrix with rank 6? Unfortunately, the answer is no. That's just not the way the universe works. The maximum possible rank is the smaller of these two sizes. So we can get the rank to be 5. This would be a full rank matrix, or at least a full row rank matrix. But we cannot get a 55, rank 55 matrix because we are constrained by this. Okay, so that's that. Again, this is the sort of thing that I use very often, and I hope you find it useful as well.